Hello, let's go ahead with spherical mirrors. Here I have shown two mirrors, one is concave mirror, other is convex mirror. Concave mirror, as I said, that it is shining from inside, inwardly shining. Reflecting surface is inward. In convex, the reflecting surface is outwardly curved. So do remember the difference between the two. Now here I have shown that what happens when parallel rays of light are coming on concave mirror and on convex mirror. In case of concave mirror, you can see that the parallel beam of rays that are coming, they are converging after undergoing reflection. They converge to a point, they meet at a point. That particular point we call it as principal focus. This P that is marked, that is known as pole of the mirror. F is focus, or it may be called principal focus, and C is known as center of curvature. The distance between P and F, that is known as focal length. The distance between pole of the mirror and principal focus is known as focal length. The distance between P and center of curvature, that we call it as radius of curvature. Why we call it a radius of curvature? Now this is actually a part of a sphere. If I complete this particular circle, then this will become a sphere. So this is a part of a sphere from which this particular mirror is cut. So certainly it has some center, and that we call it as center of curvature. So distance between P to C, we call it as radius of curvature. The other one is convex mirror. In convex mirror, you see the rays that are coming parallel to the surface. Now these rays are getting diverged after undergoing reflection from the reflecting surface of the mirror. They do not meet. They will meet only if I extend on the other side. So when they are extended on the other side, then in that case they meet at a point behind the mirror, and that particular point we call it as principal focus. Now later on we will be talking about Cartesian sign convention. Now here the focal length will be negative, and here the focal length will be positive. You will be getting more idea when I will be actually talking about Cartesian sign convention. But at present, do remember, in case of concave mirror, focal length is negative. In case of convex mirror, focal length is positive. Now then I have given the differences between real image and virtual image. This I will be also sending you. Do write down, draw even the diagrams which are mentioned. The real image, an image formed by reflection or refraction of light from the object is called real image. An image which is not actually formed by reflection or refraction of light from the object is called virtual image. Real image can be obtained on the screen, virtual image cannot be obtained on the screen. Real image is inverted, whereas virtual image is always erect. Now here we are talking about images formed by concave mirror. Now there are 6 cases, and all these 6 cases are to be drawn. I have already initially drawn. You will also be drawing in the similar manner. They are already given in the book, and refer that table 10.1, page number 164. Now here the first one, when the object is placed at infinity. When the object is placed at infinity, the rays from the object are coming parallel to the principal axis. Now I hope you know what is principal axis. Principal axis is the imaginary line that is drawn from pole of the mirror. It is a imaginary line. As such line is not there, but it is our imagination. So imaginary line that is drawn. Now here you can see the rays that are coming parallel to the principal axis. After undergoing reflection, they are meeting at F. We have already seen earlier this particular diagram. Now in this case, the position of the image formed of the object, that will be at principal focus. At F the image is formed. The nature of image, that is type of the image is real, inverted and diminished. Diminished means very very small, point like. Now here comes the second diagram. When the object is beyond C. When the object is beyond C. Now remember, when you draw this diagram, the measurement must be accurate. Suppose you are taking 3 centimeter at which you are marking F, then C must be marked at 6 centimeter. If you are taking 2 centimeter, then P to F is 2 centimeter, F to C will be 4 centimeter. So unless and until you do not mark these distances properly, you are not going to get diagram correctly. So if you have marked, if you have taken the measurement accurate, your diagram will be certainly correct. So here I have placed this particular object beyond C. The first ray is going parallel to the principal axis and then it passes through F after undergoing reflection. The second ray comes out from object and it passes through C and it meets over here between C and F. Or if you allow that second ray to pass through F and then let it go parallel to the principal axis, then also it will coincide at the same point. So either you can have this particular way or you can have that particular way. Both are correct. So here the image is formed. Now you can see the image obtained is inverted. It is obtained in front of the image, front of the mirror. That's why that particular image is real. And real images are inverted. And it is smaller than, its size is smaller than the object. So what we say, position of the image? Position of the image is it will form between F and C. And nature of image, real, inverted and small. So this diagram you need to draw. Then comes another one. When the object is placed at C, we are slowly coming closer to the mirror. So here I have placed object at C, first ray parallel, then it passes through F. The second ray that comes out from the object that passes through F and then it goes parallel. Wherever they coincide, there the image is formed. Now you can see the image is formed at C. So here position of the image will be C, nature will be real, inverted and same size as the object.